I'm Anil Kumar, and in this series, we'll take a few questions based on application of vectors. We're looking into velocity application. The question here is, a remote controlled toy car moves in a straight line, starting at -3, -2. After t seconds, its position xy in meters is given by the vector equation -3, -2 plus t times 1.52. Find the position of the car after 4 seconds. And part B is, find the speed of the car. Now that's the question for you. You can always pause the video, answer the question, and then look into my suggestions. Now, as mentioned in this question, we are actually given the position vector, right? So let me write down clearly, what are we given? We are given position vector in the form xy. So xy is the position of a vector which represents the movement of a car in a straight line. It is -3, -2 plus t times 1.52. Let us first understand this position vector itself. Now, on xy plane, I can actually sketch this in this fashion. It starts at -3, -2 and it's got a positive rate of change. So we could do kind of like this. Let's say this is xy plane for us. So this is x-axis and that is y-axis. Now when I'm saying that position is -3, -2, okay, so let's say this is like 1, 2, 3, 4, right? Say, so this is +1, +2, +3, +4, and let's say this is 1, 2, 3, and this is -1, -2. Okay. Now the starting point is -3, -2. That means 1, 2, 3, -3, and -2. So we get this position. That's the starting point. And t gives you time actually. So you can treat this axis also as time. And time is in seconds. Let me write s here. So it starts from here. And let's say every unit of time, which is seconds in this case, the toy car moves 1.5 along the x-axis and 2 above. So this is 1, 2, 3. So 1.5 is like midway here and 2 above. So it reaches this place. Do you see that? 1.5 to the right and 2 above, right? So this is moving from 3, 1.5, 1.5, correct? Okay, so, and then again, it keeps on moving this direction, 1.5 and then 2, kind of like this. So as you can see, the car is actually moving in this direction, right? So it starts from here and kind of goes like this. So that's the linear straight line motion for the toy car. Okay, it starts at -3 and that's how it moves, right? This is 2 for us. Okay. Now, let us answer these questions. I hope you have understood the scenario. Now it says, find the position of the car after 4 seconds. That means t is 4. Here time t is written by this parameter t. So if t equals to 4, we need to find position. That means xy value. Is it okay? So we'll just write -3, -2 plus 4 times 1.52, right? So if I multiply by 4, what do I get? I get the x value will be -3 plus 4 times 1.5, right? Which is 6, okay? And the y value will be -2 plus 4 times 2, which is 8, right? So the position in this case will be 3, and that gives us 6. So that becomes the position of the car after 4 seconds, right? So the answer here is 3, 6, right? So that is going to be the position. Now the second part of this question is find the speed of the car. Now this portion here, it represents velocity. As you know, distance is speed into time, velocity into time, right? Time into velocity is displacement. So that is the velocity. So speed is magnitude of velocity, right? So let's understand this part. I'll write down here, speed is magnitude of velocity. Okay, now that is the velocity for us. So what is the magnitude? Let me write down. So speed S is equals to, magnitude means 1.5 square plus 2 square. Is it okay? So that is the velocity vector, and the magnitude is a square plus b square square root. We can use the calculator, find this answer. So it is square root of 1.5 square plus 2 square, and that gives us 5 over 2, or in decimals 2.5. Now whenever we are working in applications, you have to write units. Units will be meters per second. So it is meters per second. Do you see that? So the answer for the second part is that what is the speed of the car? Speed of the car is 2.5 meters per second, right? So I hope the concept is clear. A straight line motion of a toy car can be represented by a vector equation in which the first part is the starting point. When t is 0, you get -3 -2. And t times whatever is the velocity, the constant velocity of the car. Magnitude of velocity is speed, which we found and wrote. So that is the basic concept. With this, let us move and solve few more application questions on velocity. I am Anil Kumar. Feel free to share your questions, share and subscribe my videos. Thank you and all the best.